Howdy everyone, my name is Chandler Nielsen and I'm going to be doing my Unit 4 case connections and I'm going to be doing case 1 and 2. There's my name, Chandler Nielsen. I hope you can see the date. I have to look around. There we go. Chandler Nielsen, June 9th, 2020. And I'm excited. It was actually kind of an interesting activity and these are my favorite case connections we've done so far. Anyway, I'd like to start with case 1, and this poor newborn presents, it's not even a real situation, but this poor newborn presents lethargy, apnea, and hypothermia just within a day of being alive. I'm a father of 2, and I couldn't even imagine. The doctor thinks a metabolic disorder is present and orders some various labs. Looking through the list, I know we would not need a blood glucose lab. This is because the baby, we know the baby to be hypoglycemic. It also does not give us quite the detail we need to be able to choose it from a plethora of issues with having low blood sugar. I would not have picked B because it could not rule out the beta oxidation disorders as a contributing factor. It regards a lot of the urea cycle, but not the beta oxidation. The next one on the list, number C, was a serum fatty acid lab, and it's kind of similar to answer choice B, but with the opposite logic. The lab could give us an indication of that beta oxidation disorder, but not give me further information if it's a urinary acid cycle issue there. And so these answers kind of contradict itself, and because of that, so far A, B, and C are obviously not right, and that leads us to answer D. And that's what I kind of go on further in my paper. Finally, answer D comes up with the plasma glutamine. This lab will be able to show whether or not glutamine levels are elevated or not. Low levels of glutamine will show if there is a beta oxidation disorder present. On the other hand, urea cycle disorders will reveal high levels of glutamine serum. And this is why I selected answer choice D. This will give us the idea and get us on the path of if it's a beta oxidation issue or a urinary cycle issue, acid cycle issue. So the question further on and asks about the labs that are taken, and it says, and I wrote, from the labs that are taken, we are asked to think of what enzyme is most likely to be lacking based off the presented information. Then we are also asked to find an enzyme that is not disabled in the urea cycle and is doing well. So if we look through the thing, we see that we see elevated levels of ammonia. So right there we can conclude that the urea cycle is struggling. We see some elevated levels of orotic acid, and in this urea cycle, this was a tough one for me to say, but carbamoyl phosphate synthesis produces this acid as a product. So from this information, we can kind of conclude, and I would predict that this enzyme is working well. The labs also show an enzyme called citrulline is not elevated. And then with this information, we can predict, and I can predict, that orthine transcarb amylase is having deficiencies. And I think that's the golden medal for the hardest word to say on any of the case connections yet. But I would predict that this enzyme, this orthine transcarb amylase, is having deficiencies. So that's case 1, and we've gone through the answers, and I chose answer D, and then we went through and we talked about how the enzyme that's going to be really doing well and not so well in this cycle. The next one I chose was case 2. I just started from the top and kept going down, and I'm asked to what amino acid could become more crucial to the child as a consequence of PKU. PKU makes it impossible for an individual to convert phenylalanine to tyrosine. It's usually in children, is what at least from what I've been reading online and as I've done these other questions answering the pathway responses, that are usually in children, unfortunately. But without the conversion of tyrosine, we will have these high levels of phenylalanine, which leads to the diagnosis of PKU. A patient that is lacking tyrosine is in need of finding sources of nutrition in which that tyrosine, that amino acid, is high. Obviously, because if we don't have that, we're going to struggle with this system. We are then asked to explain some things that could cause these presentations with PKU. Looking at the patient description, we see that neither of the patients have issues with, neither of the parents, not patients, that's yet to come, but neither of the parents have issues with PKU. Furthermore, no known history of PKU is found in either side's, the mom or dad's family and their family members. This information would have me to assume that both parents would be the autosomal recessive carriers of PKU. This would be really the only way that this child would get it and could emit this condition genetically. Both parents would have to have this genetic recessive autosomal to be able to have it emit in this child. There is another infant that is being considered for the same disorder. This provider is seeing the same thing. These two infants participated in the BH4 loading test. Simply stated, how this test runs is these tablets of synthetic cofactor are dissolved in water and then administered 30 minutes before a meal. The provider then takes the blood of both these babies before the meal, 4 hours after, and then 8 hours after, and then we're able to see this graphic that's provided on this case. And I read it, and this is from the BH4 loading test. And we're asked to simply just talk through the results on the graph. The graph is really simple to read, and it kind of gives a very clear answer, but it's really clear that, and this is what I wrote, it's really clear that patient A kept an elevated level of the phenylalanine even after the patient received this BH4, this loading test. Patient B is shown to not have the same high level of I keep saying phenylalanine as patient A does. Patient A, it just keeps kind of coming up. Patient B, it falls off. Patient B is shown to not have that same high level. BH4, like the case states, it's a cofactor. This special cofactor helps phenylalanine hydroxylase conversion of L-phentylalanine to L-tyrosine. And that's what we're needing in the beginning of this thing, is to get that diet up with this. But this cofactor helps the transfer of this. Based on that evidence from the graft, I can conclude that patient A has PKU and patient B does not present this disorder. So those are both of my cases. I pray that I've covered each of the questions correctly and gotten through what you asked of me to cover. Thank you for this opportunity on these case connections. And again, my name is Chandler Nielsen. The date is June 9th, 2020. Thank you, and stay safe out there.